Dear students, in this video I explain Unit 3 shift registers. The topics in the shift registers are: first one is introduction, second one is buffer register, third one is classification of registers, fourth one is shift registers and their modes, fifth one is bidirectional shift registers. These are the topics which are included in that shift registers. First one is introduction. Register is an important application of the flip-flop. So flip-flop is a 1-bit memory cell which can be used for storing the digital data. So already these flip-flops are explained in Unit 2. To increase the storage capability in terms of number of bits, we have to use a group of flip-flops. Such a group of flip-flops is known as a register. So if you want to store only single bit, flip-flop is sufficient. But I want to store more than one bit, we go for the registers. Register is nothing but combination of flip-flops connected in a such a way is called as register. The register is a group of flip-flops. The n-bit register will consist of n number of flip-flops. If I want to store the n number of bits, so n-bit register is required. The n-bit register contains n number of flip-flops. Buffer register. So the name itself indicates buffer. That means it only buffers the data, not changing the data. Generally, registers are used to store the data, not changing the data. So constructed by using D flip-flops. All the registers are constructed by using D flip-flops only. Why? Because D flip-flop is nothing but data flip-flop. Whatever the data we are given at the input side, the same data will be present at the output. There is no modification in the data, just transfer from input to output. So here register also the same purpose. Register is used to store the data, not changing the data, so that D flip-flops are suitable to design the registers. We can use any type of edge triggered, but here it is a positive edge triggered D flip-flops are used. Operation of buffer register. The data is to be stored is B3, B2, B1, B0 is equal to 1010 initially. That means B0 1 D flip-flop, B1 1 D flip-flop, B2 B3. These all are 4 D flip-flops will be there. In that 4 D flip-flops, the 4-bit data 1010 is stored initially. These bits are connected into the D flip-flops. Then the clock pulse is applied and corresponding output will be Q0, Q1, Q2, Q3 is equal to B0, B1, B2, B3 is equal to 01, 01. That means B0 output is Q0, B1 output is Q1, B2 output is Q2, B3 output is Q3. So the Q0 data is 0, Q1 data is 1, Q2 data is 0, Q3 data is 1. So the same data will be appeared in the output after some time, so that this register is called as buffer register. So the diagram for this buffer register is like this. Here 4D initially 4D flip-flops are required, so that 1, 2, 3, 4, 0 to 4. So this is the first flip-flop, second flip-flop, third flip-flop, fourth flip-flop. And these 4 flip-flops are having 4 inputs. So this flip-flop having the input B0, this flip-flop having the input B1, B2, B3. This is the 4 inputs. And this is the clock pulse applied to each and every flip-flop. The same clock pulse is applied to each and every flip-flop. So outputs of these flip-flops are, this flip-flop output is Q0, this flip-flop output Q1, Q2, Q3. These 4 outputs. So the operation of this is the structure of buffer register, 4-bit buffer register, and the operation of this 4-bit buffer register is like this. So here 4 D flip-flops will be there, 4 inputs B0, B1, B2, B3 corresponding the 4 D flip-flops, and corresponding 4 outputs are Q0, Q1, Q2, Q3 respectively, and apply the clock pulse. So this is the 4 D flip-flops. Now I want to apply 4 bits data B0, B1, B2, B3 data to this D flip-flop, so that B0 data is 0, B1 data is 1, B2 data is 0, B3 data is 1. This data is included in the D flip-flop, and apply the clock pulse to all the D flip-flops. The same clock pulse is applied to all the D flip-flops, and the corresponding outputs of these D flip-flops are Q0 0, Q1 1, Q2 value 0, Q3 value 1. So the same data will be appear at the output after some time, so that this register is called as buffer register. So D flip-flop is nothing but data flip-flop, so that whatever the data we are given at the D naught, the same data will be appear at Q naught. In the same way, Q1 D1 data will be appeared at Q1, D2 data will be appeared at Q2, D3 data will be appeared at Q3 without changing any more values. So 4 inputs, 4 outputs. This is operation of 4-bit buffer register. Next one is classification of registers. So mode of operation, the registers are classified basically 4 types. First one is serial in, serial out shift register, serial in, parallel out shift register, parallel in, parallel out shift register. So serial in, serial out shift, parallel in, serial out shift register, parallel in, parallel out shift register. And serial in, serial out shift registers again 2 types: shift right register, shift left register. So this is the basic classification of registers. So shift register, the definition of shift register. So multi-bit registers that moves stored data bit left or right, that is 1 bit position for the clock, is called as shift register. Data will be shifted by using number of clock pulses. So first clock pulses is applied, the data will be shifted either right or left, then the register is called as shift register. If the data is shifted from right to left or left to right, then the register is called as shift register. Shift register. So this is the summary of the shift register. So see, serial in, serial out shift register. So this is the procedure for changing the data from, so right shift from left to right. So the arrow mark indicates left to right. So input are applied here, and the data will be first clock pulse, the data will be appear here. Next clock pulse, the data here, the data can be converted to here or move to here. This data move to here, this data move to here, like this. So next one is serial in, serial out shift register. This is the shift left register, so that the arrow mark is like this. So here the input is given here, the data will be shifted to like this, so that this arrow mark indicates like this. Next one is serial in, parallel out shift register. So input is applied serially and outputs are connected parallelly, so that here one output, second output, third output, fourth output, 4 outputs are taken at a time. So parallel in, serial out shift register. The input data is given parallelly and outputs are collected at the serial. So this is the different types of shift registers or different modes of shift registers. So we can explain clearly. Serial in, serial out shift register, shift left mode. So serial in, serial out shift register, shift left mode register. So this is the diagram for the serial in, serial out shift register. The data will be given serially and the data will collected serially. So D in is the input. So the data are given at the D in serially, and serial data output, the data will be collected here in serially. Serial shift left register, so that the data moved from, left to right to left, because serial shift left register, so that the data will be moved to left. So before applying the clock pulse, let us assume all outputs are 0, so that Q0 output 0, Q1 output 0, Q2 output 0, Q3 output 0, and apply MSB bit of the number to enter to D in. So D in is equal to 1. So at the first time, so we are entering the D in value is 0. So next slide I will explain the operation of this shift register.